Hello guys, welcome to Houdini VFX, and today we're going to go over some particle system. Right now what I have is a Maya, a animation like this. I'm going to export it to Houdini and we're going to generate a bunch of particles swirling around this guy. Okay, so let me grab this guy and go back to frame 1. I'm going to go for cache, Alembic cache, and export selection to Alembic. Okay, and I'm gonna put it somewhere here. That's my Houdini project, and put it into the Alembic folder. I have a morphing here right away. You just use the default setting. The only thing you probably wanted to change is the start end of the timeline you want to export animation wise. I have 32 frames of repeated animation, so that's what I'm gonna do here, and export selection and replace that. It's going to be generated really fast. Back to Houdini, I'm going to go geometry, and instead of it, I'm going to delete that file and create a Alembic and load the jobs ABC morphing, right? That's going to give me the morphing animation here too. But if I play this, you can see it's only playing the first few frames. Let's turn on the real time. As you can see, it's only playing once and doesn't really repeat. If I wanted to repeat, I can change the frame here. Instead of 1, let me click on the name here to go to the expression, and basically it's reading the timeline's number. I'm going to change that to module my time or my frame range of my animation, so it will keep going from frame 1 to frame 32, but on frame 33 of my timeline is going to read back frame 1 again and keep recursively reading these, repeatedly reading the same frames. Okay. Alright. So after Alembic, I'm going to create a transform just to make it smaller because it's super big. I'm going to change that to 0.02 and 0.02. It's not getting smaller, or is it? Yeah, it is getting smaller. So 0.02. It wasn't getting smaller. I don't know why, but anyway, it's smaller now. Let me space G to go there, and let me create a sphere just to compare. Now you can see the sphere is 1 meter. That guy is 5 meters, like a huge monster, I guess. But it's your choice to either make it even smaller or just keep it this way. Okay. Alright, so my animation should still be there, but one thing I don't like is this bottom hole here. So I'm going to close it, but if you're holding down the middle mouse button here, you can see it has a bunch of, actually just 1 point. The reason being is because Alembic is basically caching reading the geometry from the ABC Alembic file, but doesn't really update it. It's basically instancing it instead of really reading all the geometry. Of course, you can do that by using a convert node. It's going to convert our model into a polygon. As you can see now, we have points, primitives, and everything here. Okay, let me go to selection by pressing S button and 3 button on the keyboard to go to edge mode. Double click on the edge, press tab button, and type in fill and polyfill. Okay, whoops. So I have filled this, and I have selected a bunch of faces too. Let me press tab again and do normal, just to fix the normal there. Let's see if we can tell it to go. Oops, that's probably too much. Let me go down just a little bit. Okay, looks better. Alright, so after that, my animation should still be there because it's basically procedural, right? And afterwards, let me subdivide it so I can have slightly more detailed model or more smooth model. And it's gonna help me to get better results or more detailed emission from my particles. After that, I'm gonna generate some variations on the surface, some attribute on the surface to emit the particle differently. So I'm gonna go for a attribute VAB. 2T attribute VAB Attribute bob will allow me to, again, using a visual programming way to do something with this model. And right now, if I press the P button, it doesn't really show me anything. But anyway, right now I'm doing that on the point level, right? That's what I need. So let's double click inside, Control B to maximum this pen. That's what they call that. They call this a pen. So I'm gonna go to P here and type in vector to vector 4 and drag the time there. It's gonna allow me to create a 4-dimensional space or time or position, and I'm gonna use that to drive a noise called anti-aliasing flow noise, basically like a river flow kind of noise or water flow kind of thing. And that noise goes, let's make it go to the CD here for now, and let's take a look. As you can see now, my geometry is being colored by that noise. Every point will have a color that is ranging from negative 0.5 to 0.5. As you can see here, CD colors are having negative values because that's what that noise do. Okay. Well, I don't really need the color just to visualize it. What I really need is actually band export a new attribute. I'm gonna call it emission. Okay, you can call it whatever you want, so don't worry too much about that. The type will be float. Okay, and then here I'm gonna change some settings like frequency. For the frequency, maybe 5. Okay. Alright. If you wanted to go faster, you can also change the last frequency, which is the time frequency, and change that to 5. As you can see here now, they're moving faster basically. Okay. Alright. After that, I'm gonna create, before I actually go for new things, one thing I didn't mention is that the dimension now is having negative values, which could cause a problem. I'm gonna clamp that. So I'm gonna say clamp right here, and the clamp goes to input, and the clamping result will be clamping the original values to the range of 0, 1, which is probably good. As you could probably recall that the emission value is ranging from 0 to 0.5. I'm now only getting 0.3, the highest. I can maybe rescale that. Maybe rescale that by maybe multiply it by 2 if I wanted to do that. Not really that important because I can also change how much particles I emit later on. Right. So I'm gonna create a float parameter, or a parameter basically. And its parameter will be allowing me to actually type in a number. Let's call it emission scale. I can change this guy here to 2, so it's basically twice as much. I'm getting closer to 1 now. Anyway, not that important, but just something you can do. And I'm gonna do a mountain right on top of it. So mountain right here. And that's gonna actually deform the model, like it's kind of like changing down the way. And under this time, I'm gonna use the time to drive it at time. Okay, so it's gonna wobble around more, and that's probably too much wobbling. Let me change the height down, and element size can be also smaller, so I can get a lot of smaller cool details on the model. Okay, let me change the height down just a little bit more. Okay, maybe just a little bit more than that. Okay, cool. So now I have a nice dynamic deforming geometry for me to emit particles. So let me do a node here and call it emitters. Emitter. Okay, emitter will be then connected to a pop network. A pop network is again basically a dot network with presets for loading the first input as the source of the particles. As you can see, everything is set up properly for you already. You probably don't need that merge, so I'm gonna delete that too. Alright, now you can see it's emitting particle already. Let me turn off the guide here. so I don't really have to see it. Okay. So after that, I'm gonna change some of the burst settings. I'm gonna burst more particles per second. So maybe 100,000 for now. And the life expectancy can be changed to something lower, like 1.5. So I don't really have, you know, a lot of particles still hanging around. And also maybe final step, give it some color first. So I'm gonna say pop Rango again. Oops, no, not there. Let's use pop Rango this time, but you can use pop VOP too. Basically, scripting coding way or visual coding way. It's your choice. I'm gonna create a CD will be equals to something, and that something will be based on the edge. So maybe this. I'm gonna make the CD equals to a channel ramp here, and that CD will be using a channel ramp down there. I'm gonna call this color over through time, and I'm using the edge, and divided by time, life, so that I'm getting the percentage of how much they have lived through their time, through their entire lifetime. And click on that button. It's going to create the ramp for me. It's a 1D ramp. To change that, you have to go to the settings here, go to edit parameter interface, and here underneath the color through time, you can change that to a color and accept. Alright, so now it's a color ramp. I'm going to change the color to start with a darker blue, and gradually in the middle, maybe it's getting a slightly brighter blue, and here another brighter blue, and eventually it goes to white. Okay. Now, as you can see, my particles are kind of like this water gradient on them. It's easier to see what's happening with those colors. Okay. Alright. So for now, it's not looking very interesting because it's just emitting particles right and not really having any velocity or anything. So what I want to happen is make the particles swirling around the body. Okay, so I need some volume or some field to drive it. Okay, so to generate a field, you need a volume. Volume and field are basically the same thing. Let me actually create one so we can do some explanation. Drag out from subdivide. I'm gonna create a bound. Okay, bounding box. Bounding box basically is creating a cube like this. That is the bounding box of my geometry. Okay, and here I'm gonna give it some padding. Change that padding to maybe 1, so it's like 1 unit away from all 6 directions, so that it has more space to generate more volume. So I don't have the particles when I generate that velocity to drive my particle, they don't just suddenly stop from the top. You have a little bit more to go. Okay, and so I'm going to create a volume based on this bounding box. It's going to fill this bounding box with a bunch of volumes. A bunch of volumes, I mean a bunch of voxels, right? A bunch of voxels will be generated here. Let me press W to go back to object mode. I'm going to change the initial value to 111. As you can see now, it's a very dense volume. I'm going to change the name to a name. You can call it whatever. So just to show that you can do that, I'm just gonna. You can do that. So just name it whatever you want it to. Right. Change the rank to velocity. So basically now this is a bunch of voxels going inside of this bounding box I have created earlier. Every voxel will have a attribute called whatever, and if you hold it down minimouse button here, I have the attribute called whatever, and at whatever, for every voxel, the whatever have a vector value of 111. Okay, that's basically what it is. Again, a lot of things in Houdini, we call them different things, but they're basically most of the time can be considered as just a attribute. And now they are just that. And the volume here is Again, a little bit chunky on the edge. That's because of the uniform sampling division. That's basically the resolution of the voxels. So I'm going to change that to 50 to, make it 5 times more detailed resolution-wise. And now I have this. Okay, again, this is boring, right? It doesn't really have any different inside. So I'm going to create a volume up to actually vary something inside. Okay, let me double click to go inside. I'm going to delete its density, and I'm going to create again a vector to vector 4 to allow me to generate a 4-dimensional position using position and time, and use that to drive a core noise right here. And the noise results goes to band export, and it's going to export as a 3-dimensional, a vector basically, and name will be the whatever I have earlier. So this will override the value from my original whatever value, which are all ones, now to the noise I'm generating here. Okay, so this is what we're having for now. Let me go back and let's actually visualize it using the old good slice, volume slice, and also from there we can go for a volume trail. Okay, the result, the second input will be the volume. As you can see now, I'm seeing the lines from that volume or that velocity field. Basically, I call that velocity field because I'm using that as a velocity driver of my particles. But it's basically a volume of a lot of voxels inside of it. Every voxel have an attribute called velocity. It's a vector attribute, so it has 3-dimensional attributes. Or that's why when you see how they change down the way, they're forming a line based on the direction change. Okay, and you can change its offset to go to different portions of that. This is basically slicing that particular volume and just view it in just one little slice of it. Okay. All right. So this velocity field or volume, again, field is being called volume when they're just volume. If you're going to use them for something else, like driving particles, you can also call them field. Again, basically the same thing, so don't get too intimidated by the naming. I'm going to grab that results to the second input of my DOP network, and here inside of it, I'm going to create a pop advect by volume. This is going to allow me to use that volume I created to basically make my particle flow with those lines. Alright, so here I'm going to grab it and change the velocity source to second context geometry, which is basically what the second input is. And be sure that you're using the volume instead of those visualizing things. Okay, and here let's go inside, and you can go to guide and turn on guide so that you can see them if they're not updating. Right, you can go back and check if you're using the correct field name. I was using the whatever thing, right? So let's change that to whatever. As you can see now, I'm now having those beautiful lines to drive my particles now. The advection type is update force, which will update, push them around using those lines. You can make them follow the lines exactly by using update position. And that's what I'm going to do here. Okay, and let's take a look, right? So if I go and play the animation now, as you can see, my particles are now going out and being dragged around by the lines here. Okay, pretty cool. So that's something that we have. If you're happy with this, you can probably go just go to rendering, but I actually want the particles to somehow a little bit getting closer maybe to the body and swirling around it, if that's more like flows, right? Doesn't necessarily to be water, but nice flows to have the particle behaves better than just randomly go around. Okay, so to achieve that, I need this swirling noise to interact with my body. Now I can't do that with the body of this guy. Actually, you can do that using a sun distance field. Sun distance field is basically a field using positive value to represent the outside of the geometry and negative value to represent the inside of the geometry. You can actually generate that with just one node called VDB from polygons. This will allow you to create that. Okay, Again, this is basically also a bunch of voxels, and you can change the voxel size to 0.025 just to get a much more detailed result. And this is basically it. One thing you probably want to do is also make it go further away from this geometry. So I'm going to change that to use word spaceband and change that to 1, 1, so they are basically expanding. You don't really have to change the second one because that's the inside. Just change the outside one. Okay, so that's going to make it also extend out that much. And for every voxel, maybe here it will remember that this voxel will have a value of positive probably 1 from the distance you can see here. And this voxel could have something like really small, like 0.5, but it's still maybe 0.1. It's still on the outside of the geometry. The voxels inside though will be having value of negative values. And also, when the value is 0, that's when you see all those smaller planes to represent that's actually where the surface is. Okay, so this is nothing more than just positive and negative values and giving you a visualized geometry here just to show what's happening. Anyway, so don't get too intimidated again. It's just again a volume with voxels inside, and every voxel have a float value which ranges from positive to negative values. That's what sign means. Sign means a number that can go both positive and negative values, and you can grab that to the volume of second input. Okay, because you can use the second input right here to connect to the SDF. Okay. Alright, now if you go and visualize the things, now as you can see we have a bunch of lines around the body, and just to visualize it better I'm gonna go grab this guy and change the detect range out so we can see more stuff, and I can drag that up to maybe to 3, I'm not sure yet. Okay, now I have this swirling effect around it. Let me go to the volume VOP here, and let me promote everything here so I can change them. Holding down my mouse button, promote parameters, everything here except that these 3 we don't really need that. Maybe we can have the bounce, right? Enable the bouncing, probably don't need that, but this SDF and the other 2, they're basically 2 different ways of make it interact with geometry. We're using SDF, we don't need the other 2, so that's what that is. Alright, so now I can go here and change some settings on this guy, like frequency for example, to have more frequency or lesser. Right, I can change the amplitude to make it weaker or stronger. Another interesting part is that setting here is the surface radius here. If you change that to something bigger, it's gonna go affect more. And 1 is the default setting, right? And that's actually just trying to trace 1 unit away. Again, that's also the information, all the information we have from the sign distance field. Okay. But you can tweak that if you wanted to. Alright. So now let's go to the particles and let's take a look. You can see the lines are changing a lot now, and if I start simulating, you can see the particles are going swelling like crazy. Let's actually take a look at the flipbook so we can really see it. And let me turn off the guide for now. Go back to frame 1. Let's do a flipbook and see what's going on. Alright, as you can see now all the particles are starts to swirling around the body, although they look too big now, but as you can see it's doing something pretty cool now, and we just need to refine the values and settings in that core noise to make it look better, but for now that's what we're having. Okay, so that's gonna be it for this tutorial, and next one we're gonna go ahead and refine this shape. Okay, see you next time.